Okay.
Yeah, so can you hear me?
Yes, yes.
Okay. So let's have a brief discussion about GCD. So according to you, like if you are given a number, like let's say A is 2 key power 7 into 8, not 8, it's 13 power 21 into 29 power 78, and B is 2 power 28 into 29 power 17 into 13 power 12. So what do you think the GCD would be? The greatest common divisor?
Of like both A and B.
Yeah, A of A and B.
It has to be like the least power in the common base for like
Oh,
both in the both prime factors of both A and B.
acha, so it's like 7 or 28, so it will be 7 because 7 is less than 28, right?
Yes, yes. So like 2 to the power 7 will automatically divide 2 to the power 28.
Ah,
So that's
yeah,
the
that's a
reason.
great concept. Yeah, 2 7 or lottery into 2 28. Yeah, and will it be the only answer or there is something else also?
Yep, yep. Because we have 13 also in common and 29 also in common. So we will take the least power.
Okay, so you are saying it's this.
Yep.
So Anant, like it's a discussion. What do you think GCD intuitively?
Like it has to be the first thing is that it has to be that common divisor of
Okay.
any number. Like if we'll take like a b, not just a b, like we can take a b c d and like till infinity. It has to be that common divisor that will divide till like whatever number amount of number we have taken. So it has to divide that thing. That's the first thing. And it has to be the greatest among it. Like you will have a common divisor, okay,
Hmm.
and the GCD is that it has to be the greatest among it.
Acha, okay.
Like
So,
like the
uh-huh.
the example we have taken. Let's go back to that example. I think this one. Yeah.
Hmm.
So like here we have 2 to the power 7, 2 to the power 28. We can also say that 2 to the power 4, 2 to the power 5, or like from 2 to the power 0 to till 2 to the power 7. We have like all of them are like common uh, divisors of A and B.
Yeah, yeah.
Also like till uh, in case of 13 till 0, 13 to the power 0 to 13 to the power 12, but we have to take the greatest among them, so that's why we took 7, 12, and in case of 29 it is 17. So that's the
Yeah,
thing.
yeah. That's a good approach. Yeah, for real. So, if we
Yep,
take an example of 12, so we can say that 1 divides 12, right?
yep.
2 divides 12, 3 divides 12, 4 divides 12, and 6 divides 12. So, if we take 18, not 18, we
I
have
think we
taken
have
the
discussed
previous.
this thing.
Yeah, yeah, yeah. Let's take a big number, 128. That's it. Hmm. So 1 divides 128, 2 divides 128, L 4 divides 128, 8 divides 128, 16 divides 128, 32 divides 128, also 64 divides 128, right?
Yeah.
So, Anant, I want you to visualize like for, let's say the divisor we denote as D. Okay.
Yes.
So D of
Like
12 is,
just
yeah, yeah,
okay.
12.
Nothing.
Achha, my voice is right here, right?
Yeah, yeah, yeah.
So D of 12. One is common in this case, so we are excluding one for now, just because, of course, one divides any number.
Yes.
So it's 2, 3, 4, 6. 12 divides 12, but we are not taking that case. Okay. If D of,
Like of
yeah, we
course
can
that
take,
it is like almost same like that
yeah,
the one divides 12 and that thing.
uh-huh. D of 128 is 2, 4, 8, 16, 32, 64. Got it?
Yep.
Now, if we take two set like this, and it's 3, 4, 2, 6, 8, 16, 32, 6, 32, 64. You are getting what I am just doing right now?
Yes. Like you're
Hmm.
writing like all the divisors like it is for set A actually not set like set 12 set of divisors of 12 and it is for 60 or 128 and
Hmm.
of course the common are in the intersection part
Yeah,
of
yeah.
the set.
So we can say from your definition, like 4 must be the GCD of these two number, right?
Yeah, because
Correct?
like we have 2 and 4 as common divisors,
Hmm. Hmm.
so we have to take the greatest among them. So of
Yeah.
course 4 has to be the greatest.
Achha, Anant, give me two. How I want to show you how powerful this statement is. Give me any two number which are factorable, doable.
Wait, you can take like 33 and what? Let's take
No,
like
no,
some
big number,
unconventional number.
big
Wait,
number, which has like
ah,
lots of factors, so we can visualize it nicer.
like 7 and that all stuff.
So let us take A1 as 2 into something like 2 into 5, 3 into 4, 5 into 6,
7, mm,
7 in
11,
7 power 11, okay. 11 power
13.
13. Okay, okay. So yeah. And let us take A2 as 2 power. What should we take power here?
Like take 7.
Okay. 3
You can
power.
take anything like
Let's say 3 power 0.
11.
Uh,
Yeah,
5
that
power
works.
8. 7 power 7. 11 power 12. Okay. So I want you to visualize it like 2 power 5.
I think you should also make 13 to the power 14 as the factor of A2. So like we can see that even if that A1 or A2 is bigger. Yep, yep. Oh no, not like this. Not 13 in one case, but 13 in other case. Like
Okay, okay.
this thing. Yes.
So yeah, we can say that A1 set, we are defining our own set. It's just like number of elements, the common divisor.
Yep.
It can be repeated. Means usually the elements it's in sets are not repeated, right?
Yep. Yep.
But in for our convenience, we can repeat. So it's 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, till 6 times 5, 11 times 7, 13 times 11, and 14 times 13. So you're getting, like, if we represent two numbers like this, let's make the intersection bigger. So it's like 2 power 2, 2 power 5, right? 3
Yep.
power 0, and okay, okay. 5 power 6, 5 power 2. Let me write it. And Okay, 7 power 7 and 11 power 12. Yep.
Nice.
Now it is 7 power 4. Just give me some, like a minute or so. 11 power 2, 5 power 6, and 3 power 4, and 13 power 14. Now, can you see what I have done?
Yeah, like you have listed all the divisors for A1, A2 in two sets, and in the intersection part, we have all the common divisors of
Hmm.
A1 and A2.
Hmm.
Yep.
So, so you can see like A2, what we have defined is 2 power 7. See, oh, okay, sorry. Let me scroll it. Hmm. A2 is 2 power 7 into 3 power 0 into 5 power 8. So it is the same thing here. 2 power 2 into 2 power 5, it is 2 power 7. 3 power 0,
Power
5
7.
power 8. So it's same. A2 number and A1 is same. But here we can see what is common here.
Yeah, like we
Now,
have two, like
yeah.
2 to the power 5, and that's all
Hmm.
common.
Now, Anand, I wanted to prove something. If C divides A2, C divides A1, then Anand prove that C divides GCD of A1 and A2. If
Okay.
C is
So,
not,
like,
C is, yeah, C,
please,
nothing, no condition.
okay. So, like, you can, if C is dividing A1, so you can write A1 as C into some integer, and same with A2.
Hmm. Then,
Yeah. So, the first thing is that, okay, wait.
and just think about set. Don't go in this
Oh,
modular
yeah.
arithmetic.
Yeah,
Think out
yeah.
from here. What we can, it's a
Wait.
complex, not complex,
Yes.
but lengthy proof. Yeah, you can think from here.
We can say that C is common divisor of A1 and A2, so it will lie in that intersection part.
Yeah,
Okay.
yes.
Uh, and we have the GCD as the greatest among in this intersection part. Okay.
Yeah, like GCD for here is 7 power 7 into 2 power 5 into 5 power 6 into 11 power 12. Hmm.
Yeah. And C has to be like among one of C will be one of the elements among these because
It
it
can,
is common divisor of A1 and A2.
yeah. So
It
it
can
can
be
be
like
7,
anything.
it can be 5 into 6,
Yeah, anything.
anything from inside it.
Yep, yep,
Yep.
yep. So definitely it has to divide the like whole GCD part.
Yeah, I mean, we can we can say that C is a subset of GCD, the intersection of
Yep.
A1, A2, right?
Any common divisor has to be like the subset of the greatest common divisor.
Yeah.
Like
So
you
from
can
here
think
we
it
can
like
easily prove this.
yeah. That is I think that's a good approach. Like not going in that way.
Hmm. That's what I wanted
Yeah.
to show you. Like we can prove statements from set theory also, like for GCD
Yeah, and
and
it's a good
number.
approach. Like not very complex and not going into some great calculations.
Yeah.